This video is going to describe the different parts of a circle. And some we've already learned this year, so we'll review those and then we'll introduce some new vocabulary, some new parts of the circle. So a circle is the set of all points in a plane that are equidistant from a given point called the center. So here would be the center, and then all of these points highlighted in blue here are equidistant from that center. So that's the circle. The radius is a segment that connects the center of a circle to a point anywhere on the circle. The plural of radius is radii. So one radius shown here in red is from the center to a point on the circle. That's the radius. The diameter is a segment that connects 2 points on the circle and passes through the center. So in green here we have an example of a diameter. It connects 2 points on the circle, a straight line, but it goes through the center. So there's a special relationship between the radius and the diameter. Okay? The diameter is 2 times the radius. So the radius is the half of the diameter. And the last is the circumference of a circle. You could think of it as a perimeter, but we use the word perimeter for our polygons, so our straight edge two-dimensional figures. But circumference means the same thing as perimeter. It's the distance around the outside edge of the circle. So what would be the distance from here all the way around back to here? That is the circumference. And there's formulas for that. There's two. You could either do circumference equals 2 pi r or pi d, which makes sense since the diameter is twice the radius. 2r here equals d over here. So diameter times pi or 2 times the radius times pi. Now, some new terms. Chord. A chord is a segment that connects any 2 points on the circle. So in this example, we have 2 chords shown, DE and BC. Because diameters are segments that connect 2 points on a circle, there are also chords. So a diameter is a special type of chord, okay, because it goes through the center. But all diameters are chords, but not all chords are diameters. So DE is a chord, but it's not a diameter because, again, it doesn't go through the center. So any segment that connects 2 points on the circle is considered a chord. An arc. An arc is part of a circle that is formed by 2 points on the circle and all the points that lie inside those 2 points. So in this example, okay, so we have 2 points on the circle, CD, so that would be a chord right there. But the arc, the part of the circle highlighted in blue here, C to D, that's the arc. So part of the circumference, part of the circle, and it has 2 endpoints. There are 3 sizes of arcs. There's minor arcs, major arc, and a semicircle. A semicircle is an arc whose endpoints are also endpoints of the diameter. So in this case, the diameter is LM. It goes through the center P. So this arc here in blue is a semicircle. It is half of the circle. Now, how do you name a semicircle? A semicircle is named by 2 endpoints of the arc and any letter representing a point in between those endpoints. It doesn't matter which endpoint is named first, but the in-between point must be in the middle of the name. Okay? So again, this one that we have that went from this L all the way over to the M, we're going to use 3 letters. Okay? Because we have to know which semicircle. Is it the one here highlighted in blue, or would it be the other side? So the only way to tell which semicircle we're talking about is you have to tell it what of the points that are between those 2 endpoints. So in this case, we did L, J, M. You could also name it M, J, L. Another name could be, again, any point that's between those 2 endpoints. So we could use the G, and it would be L, G, M, or M, G, L. Can you list some other ways to name this blue semicircle? Now, a minor arc is an arc that's smaller than a semicircle. A minor arc is named by 2 letters, so there's not 3 letters. There's no need because if it's a minor, if you see 2 letters, you know it's a minor arc. So the blue arc here can either be named G, J, or J, G. Okay, there's no need to name that 3rd letter in between because it's a minor arc, it's 2 letters. It's telling you if it was GJ, you couldn't go around this way because that's a major arc. That's bigger than a semicircle. When you see 2 letters, you know it's less than a semicircle, so you're going to take the shortest distance between those 2 endpoints. Can you list some other minor arcs? A major arc is an arc larger than a semicircle. So a major arc is named by the 2 endpoints and a point in between. Okay? Examples of the green arc would be G, N, M, or M, N, G. Again, because there's 3 letters, I have to start at the G, and I'm looking to go to the N first. So if I went this way, I would have to pass M. That would be incorrect. So I go to the N and then to the other endpoint M. And it doesn't matter the direction as long as the in-between point is in between the name. And the 2 endpoints represent endpoints of the major arc. What are some other ways to name the green arc? Central angles. An angle inside the circle in which the vertex is the center of the circle and the 2 sides of the angles are radii of the circle. So again, we highlighted the central angle here in green. Notice the green central angle. It could be called angle LPN or NPL. Remember, the vertex goes in the center. So since P is the center of the circle and LP and NP are radii, they go from the center to a point on the circle, the radii, then this angle here is called a central angle. Can you name another angle, not central angle, that is not highlighted? Now, to compare it against the central angle, we have an inscribed angle. So the difference between the central angle and the inscribed angle is important. And an angle inside the circle, so it's still inside the circle, whose vertex lies on the circle. So it's not at the center. The vertex is on the circle, and the 2 sides of the angle are chords of the circle. So just go back real quickly. Central, the vertex is the center of the circle, and the 2 sides of the angle are radii. For an inscribed angle, the vertex is on the circle, and the 2 sides of the angle are chords. Notice the blue inscribed angle. We could call this SLM or MLS. In this particular example, the vertex again is on the circle, LS is a chord, and LM is a diameter, which is also a chord. But you could also have a inscribed angle that does not include a diameter. And there's an example. K in red. KOM or MOK is the vertex is on the circle and the 2 sides of the angle are chords. And that's all the new vocabulary for this unit, talking about all the different parts of a circle, and we will be learning how to find the measurements of arcs and the angles, inscribed angles, and central angles.